Okay, I'm going to continue talking about measuring perception and continue to move forward through these various kinds of measurements. If you remember from last time, we talked about some of the basic classical psychophysical methods. So the method of constant stimuli, the method of adjustment, and the method of limits. And we also talked about how we can use these to measure absolute threshold. And we also talked about difference threshold. So far we have just talked about the detection of stimuli and measuring this absolute threshold, which tells me when can I detect a particular stimulus. And that in itself is really interesting. I gave you some basics of human detection, that we can see, a candle from 30 miles away on a clear dark night or whatever. That's interesting. But those psychophysical methods also allow us to learn about the mechanisms responsible for experiences. And one example that we will talk about very soon, as we are talking about the eye, is the dark adaptation curve, and what this tells us about the mechanisms of the eye and how we adapt when it gets dark. So we all know, right? We've all had this experience of we walk into the outside in the dark, or we walk into a movie theater, let's say, when the lights are down. And when we first walk in, it's like this picture on the left, where if there's some kind of light behind something, we might be able to see it, but we can't really tell where we're walking, so we really have to just stop and wait. And as we wait, things start to look more and more like the picture on the right, where we can kind of see where we need to put our feet in order to get to the next step, and that takes time. Well, we learned about that dark adaptation curve because of one of those classical psychophysical methods, the method of adjustment. So people would start off in the light, but then we'd turn all the lights off, and we'd say, can you see this flashing test light? And they would turn down the knob lower and lower on that flashing test light until they could no longer see it. And so that was the method of adjustment, right? As they're turning this knob and just adjusting the light. And then we gave them time for their eyes to adjust, and they continued to, we could see them get more and more sensitive to that flashing test light, and their threshold went further and further down. And we learned about really dark adaptation and the mechanisms responsible, which we will talk about in the next chapter. Five additional techniques that the textbook goes through for measuring perception. There are many, but 5 of the more basic additional techniques that are more psychophysical, not getting into, again, those physiological measurements that we're going to wait for. So the first one that they discuss is magnitude estimation, and they've kind of picked and pulled this apart so that it's in several different places, and I'm going to try and put it here in one place. And again, I'm going to tell you that if the math helps you, that's great, but you don't need to ever do any calculations for this class. I'm going to, as much as possible, try to give you some of the math and some of how this works so that it helps you to understand, especially if you do like math, especially the kind of conceptual part of math. It's very, very helpful to kind of imagine. But if you don't like math, don't worry about it. You're not going to have to calculate these things, but you do want to recognize this formula. So what we know of subjective magnitude, so these subjective changes, when we ask of the difference threshold, we're asking, are these two weights different? Yes or no. But now we might ask, how different are they, right? How much more weight is in the right hand than in the left hand? How much louder is that commercial than the television show that I was just watching? You know, how that change, that we usually hear those commercials and they sound like they're so much louder. How much louder? It tends to draw our attention, right? So it's louder enough that it draws our attention. We certainly noticed this change, this difference. So what we know of subjective magnitude comes mostly from S.S. Stevens, who worked in the 1960s, and he put on it this power law. This formula kind of formalizes a lot of what Fechner did say and understand about magnitude estimation. S.S. Stevens had a more precise way or method of measuring magnitude estimation, and then he put this power law on it, where the power law is the perceived magnitude, which we're going to call P. So how I'm perceiving that stimulus is equal to K, some constant, which they have figured out for us, times the stimulus intensity, so my original stimulus, or the standard stimulus as we called it before, that stimulus raised to the power n, so now we see, and the thing to notice here is now we have this exponential relationship between the stimulus and my perceived magnitude. And what that allows for is it allows for response compression. So in the example of brightness, our n is equal to 0.5, so we're basically taking the square root of that standard stimulus and then multiplying it by that constant. And then it also allows for response expansion. So if the n is greater than 1, we're going to see this response expansion as we see in electric shock. If I give you an electric shock and we're saying, hey, this is about a 2, the next time we double that, and you're going to feel that as more than doubled, right? It's going to be to an exponent of 3.5. Just to go through this magnitude estimation, I was going to try and put in a figure, but I didn't really figure out how to do that so that you can see the figure from the textbook that this response compression allows us. And I'm going to, while I'm doing this, answer this green question. But I do, so pause, think about the green question of why we might have different power functions for different senses. And here's that pause for you. Please pause it. Think about that. Why would we want a response compression for like a bright light? Or actually we have a response compression for sound as well, for the loudness of sound. Versus why would we want response expansion for something like electric shock, right? And actually, so we also see, we can look at line length. The line length has an n of 1, so that has a linear relationship. If I have a line, it's 2 inches, I double it to 4 inches, you say, hey, that looks like doubled, right? If I quadruple it, it's 8 inches, you say, hey, that looks quadrupled. So that magnitude estimation is we're really kind of right on for line length. But for brightness of light, for loudness of sound, we have a compression, and this makes sense. Okay, this makes sense evolutionarily. We're going to see this actually in any animal that has these senses. We're going to see a similar kind of compression for brightness and for sound, because we want to hear those little tiny sounds like the leaves rustling, but we don't want to have damage to the system because we're in a rock concert. We actually do have damage to the system when we're listening to a jet airplane or something taking off, if it gets over the level of pain. But we want to protect our systems. And same with brightness. When I'm inside and I'm looking at something in the dim light, I go out into the sunlight, and sometimes, depending on the day, it's 10,000 times as bright. Well, I want to be able to see what's in that dim light, but then not go out in the sunlight and have so much brightness that I'm actually damaging the system. Whereas if we look at something like electric shock, right, this is telling us, hey, this is something that's dangerous, and so, or heat, something that's hot, and at first it's going to be a little bit painful, but then we double that heat or that electric shock, and we want to feel that as more, right? We want to know that this is that much more dangerous, and we will damage the system. So this is a warning system of that danger. Another additional technique he talks about in this early chapter is recognition. So if you remember early on, I talked about how in that perceptual process we want to distinguish between perception and recognition. So we might actually just have somebody name an object. So we put the picture up that's on the right, and we want them to say, duck, basically, or that is a duck. And we measure that naming time, or we just make sure that they have the category correct. And what we're looking for is categorization. Can they categorize the object, and are they recognizing it? So our third technique that they discuss is reaction time. And this is a picture trying to show this basic task of, if you see the A and the B, the job of the participant is to put their fixation on that fixation cross in the middle. And what the researchers did was they would have something like a dark bar come up at A, and then that would be like a warning signal. So most of the time you would get the target up at A, and your job is to press yes, I see the target. So just press a button when you see the target. And but there would be some fewer trials though, where the dark bar would come up at A and the target would come up at B. Okay, and so you're supposed to still say yes, I see the target. But you can see that if the dark bar comes up at A and the target comes up at A, it looks like, even though your eyes are on the fixation cross, that you've put your attention over at that dark bar, as it's kind of this warning that you're going to get this target there, and you're faster. You're about 50 milliseconds faster to say, yes, I see the target, than if that target comes up at B after the dark bar came up at A. So it looks like we have, even though we're looking at one place, our spotlight of attention, we can have some covert attention to another area of space. Another technique is just description, which is more of a phenomenological report, asking people what do they see, which is a more qualitative measure. I usually do this in class and ask people, what do you see in A? And for most of us in psychology, this really ubiquitous ambiguity, visual ambiguity, for me, I go back and forth very quickly between the faces and the vase, and it's a little bit frustrating actually, and I think it's just because I've seen it so many times, but oftentimes people will see the vase or see the faces. We're always going back and forth. We never see both at the same time, but some people get really kind of stuck in one interpretation. And in B, I get different reports from students about tic-tac-toe boards and 9 boxes and so forth, but what I'm kind of looking for, if you look at B, you will notice that at the intersections of those black boxes, there are these kinds of darker squares, these kind of gray ghosts, as they are called. And if you move your eye to that actual intersection, it goes away. And you can see that gray ghost in the other intersections that you are not fixating on. We are actually going to explain why that happens in a later chapter or in a later lecture. So that's a more phenomenological report. I'm just asking you to describe what you see. The final technique they talk about in the textbook is having people do physical tasks or making judgments. These are actually 2 separate things in my mind, but they put them together. But we can do this either way. So a physical task, there's an example in the taking action chapter where they have people close their eyes. I think they actually blindfold them. They show them a target out in the field, they blindfold them, and then the person walks to the distant target, and they're actually pretty good at this. They can even have those people look at the target, they blindfold them and walk 5 paces to the left, and then go to the target as accurately as possible, and they're still really quite good at getting very close to that target. And this tells us, right, that we are doing this kind of spatial updating of our mental map, and that we are taking into account information like the movement of my legs and my stride and the length of my stride and all of those things in order to get that close to that target. So that's one good example of a physical task, but we can do this as just judgments. So one of the studies that I think they've taken out of the book, but I think is really kind of cute and funny, this tells us something about ourselves. If we are looking at a hill and we're asked to judge the steepness of that hill, and you put a light backpack on my back, then I judge that hill as being less steep than if you put a heavy backpack on my back. So apparently we are taking into account mentally this perceived effort that we would have to go through as we are just judging the steepness of that hill. So again, physical tasks, judgments, we can have people do either of these things. So Goldstein has taken signal detection theory out of Chapter 1 and put it into Appendix D. And over the years, I have talked about this less and less and explained it less and less. And I really don't, I'm okay with that. But if you have any questions or are at all interested in signal detection theory, it makes some very good points, some very important changes in methodology are taken into consideration. So originally, if we look at those classic psychophysical methods that we saw from Fechner, there are some problems with that. If you remember, Fechner always had a stimulus that was being presented, and sometimes it was below threshold and sometimes it was well above threshold, and he was measuring absolute threshold. And for what he was doing, for measuring absolute threshold, when they were measuring difference thresholds, they were averaging across many, many people. And so a lot of this didn't really matter. But sometimes we want to know about individual differences. Really, these questions came about in the 1940s when we were starting to try to apply some of these psychological theories and hypotheses and methods to things like people who were looking at radars and whether or not they detected some enemy blip, whether they were confusing enemy blips with friendly blips, or whether they weren't really catching that blip at all. When we're looking at an individual and we're measuring absolute threshold, we have to realize that there are a number of things involved that make this much more complicated than just, are we getting at their absolute threshold if the stimulus is always present? First of all, people differ in their motivation. So do I want to, am I taking a hearing test because I hate missing things that people are saying, and so my motivation is that I really want to make sure that I hear something before I say I hear something? Or am I taking a hearing test because my daughter or granddaughter is making me take this hearing test because they think I don't hear them and I don't want a hearing aid? So that motivation is going to mean a really different kind of where I'm placing my threshold in all of that. In addition, there's always noise. There is noise in the environment. There is noise in the system. There's always neural firing. So there's this kind of internal noise. And so there's always this uncertainty. And because there is this uncertainty and these differences in motivation and this noise, sometimes if we're looking at an individual and that we do use these same kind of methods for measuring now, for hearing tests, if we're using these kinds of methods for an individual, we have to realize all of these problems with that kind of classic psychophysical approach. So signal detection theory was introduced, if I remember correctly, in the mid-1940s. So if I want to measure an individual's absolute threshold, so I want to know whether or not someone needs a hearing aid, I really probably don't want to use Fechner's classic psychophysical methods because we know that people's motivation differs so much. So with a signal detection kind of method, now the stimulus is not always present. Okay, we're going to choose some stimulus strength that we think is right around their absolute threshold, and sometimes it's going to be present and sometimes it's going to be absent. we know that noise is always there, that they always have this uncertainty, and they have differences in motivation. So we're going to see 4 possible outcomes. So if the signal is present and I correctly say, yes, I hear that, I'm just going to stay with the hearing example, that's going to be called a hit. If the stimulus is present and I miss it, that's going to be called a miss. So I say I don't hear anything. That's a miss. All of these names make a lot of sense. If the signal is absent and I think I hear something, so I say, yes, I hear that, that's going to be called a false alarm. And if the signal is absent and I correctly say, I don't hear anything, that's called a correct rejection. Okay, and now we can look at the proportion of hits to false alarms, and we can see something about the response bias of the perceiver. So this is their response criterion of what is their motivation and where are they in this kind of how much do I want this hearing aid, basically. And we can manipulate that motivation with people sometimes, but what this proportion of hits to false alarms gives us is a better idea of their absolute threshold. And if we can find a way to manipulate that response criterion, we can get a better idea. So sometimes they do this with offering, in studies, they do this with offering money to people and changing the outcomes. We can get a better idea of their actual absolute threshold.
Typically, I'm not very good about putting up these summaries, and in class, I try to get the students to tell me what did you learn about absolute threshold or difference threshold, and so forth. But here is what we've been through, right? Other than those general approaches, we talked about absolute threshold, the minimum amount of stimulus energy required for you to actually experience that stimulus, the difference threshold. How much of a difference do we need for you to tell that two sounds are different from each other? And then we talked about the classic psychophysical methods for looking at absolute threshold, the method of limits, the method of adjustment, and the method of constant stimuli. And then we went through those 5 additional techniques that the book goes through, including magnitude estimation, naming, reaction time, phenomenological report, and then using physical tasks or judgments. And then I did not actually go through signal detection theory. I just went through, here's sort of how they do it and why they do it. But there are some mathematical, again, computations for getting those response criteria, or those receiver operator curves to give us a better idea of what people are actually able to hear or see.